Okay, ladies and gentlemen, it's 12 o'clock and we should continue with our program. Track A or Track B or middleware track. I don't know what is your preference, but since you're here, let's go with our next lecturer. Let's see the video. Christophe Willemsen is already a sort of host here and he loves Belgrade according to his tweets. Christophe is a principal consultant at GraphAware, helping companies around the world succeed with the Neo4j graph platform. Is that true? Sure. Okay, Christophe, fire at will. Thank you.
Thank you. Good afternoon. Thanks for coming to my talk. I will speak about recommender systems with Neo4j and in PHP. Before I start, who already used or heard about Neo4j graph database? Not bad, 5%. All right. Who here already built a recommendation engine in any language or with any database? Wow, cool. All right, so before going deep into implementations and Neo4j itself, I want to start first with the challenges of a recommender system. Then I will introduce Neo4j, a very quick introduction. I will speak about Reco4PHP, which is a recommendation engine skeleton atop Neo4j. And I will show you real-life examples of recommendation engines, but also bad examples, because recommendations can be served wrongly. So first, the challenges. What my colleagues and my friends are thinking when I'm speaking about recommendation engines, it is mainly I'm doing this. So, but my life is much, much more simpler than that, fortunately. So, because what can be a recommendation engine? It can be very simple at the end. It can just be recommend news you should read or books you should buy, which talks to attend, for example, based on the talks you watch or attended before. Which service is best suited to handle a failure? So we have seen application of recommendation engines in microservices architectures, for example, or finding candidates for medical proofs, etc. The first business challenge as a company is finding things to recommend to the user. The second challenge, which is very important, is serve the most relevant recommendations. The third challenge, which is an additional step that is commonly forgotten, is measuring the quality of recommendations. It is very important to measure how good and how your users are interacting with your recommendations. The last challenge is more time to market, cost of development. This is where actually using the right technologies to build the recommendation engines help companies to develop faster. As an example for this first part, I want you to imagine that you have to build a feature. This is called people you may know on LinkedIn. So I believe everybody already opened LinkedIn once. So you know that they recommend you people that you might connect with. What is very interesting is, for the first business challenge, is finding other people you might want to recommend to the user. There can be a lot of different ways of doing that. It can be common contacts on LinkedIn, Facebook friends in common, for example, if you have access to some phone features. Mobile email contacts in common, contacts of your contacts. If you work for the same company, if you studied at the same school, if you share the same interest also can be skills on LinkedIn, for example, or if you live in the same city. All those features are possible ways to recommend new users to connect to a specific user. And here the list is very shortened, because if you look at LinkedIn, there are hundreds of ways to be able to recommend user. But that's just the beginning, because once you have found the ways you want to recommend people, your problems will start. Because you have to think a lot and make decisions, make trade-offs. First is more contacts in common. Do this person will be more relevant to you or not? Generally, yes, but sometimes not. You have really to evaluate this. If you worked at the same company or studied at the same university or live in the same city, is it more relevant, and mainly, does the size of those things matter? If you work, for example, in my company, we are 25, there is much, much more chance that I will know everybody in my company than if I worked for IBM, for example. So you have to measure this and understand what you are doing. What to do, for example, with emails that doesn't represent the person. It happens on LinkedIn. They will recommend you info@coolblue.nl because it is in your contacts. So do you want to recommend this to users, to your users? No. Lastly, what should we do with contacts that are pending? So people that already made a connection. You know that you asked for it, so do we have to recommend you people you already asked a connection to? Do you want to recommend people you rejected? So if I say, no, this one is a spam, I don't want you to recommend me this again. And this is a very interesting part, is recommendations that are constantly ignored. So if you recommend me on the side of a page every day, the same persons, because they are the more relevant, if I am never interacting with your recommendation, you have to take action. You have to track what the user is doing, but most importantly, you also have to track what the user is not doing with the recommendation you serve. So you have to track this. This is the subset of business challenges. Next come the technical challenges. We could identify 3 big challenges, which is first the simplicity of the implementation, the performance, and the flexibility. So for the simplicity, I will introduce Neo4j. You will see why the simplicity, Neo4j makes recommender systems simple. So Neo4j is based on the labeled property graph model. So in the graph, you have nodes or bubbles, which represent actually objects in the graph. So a person, a car, a movie, another contact, etc. And nodes can have a label. So here, person and car. You can see a label such as a MySQL table name, for example. This is different, but it serves to group nodes of the same domain together. The thing is, a node can have multiple labels, so without additional cost. So you can have person, but also administrator, for example, on this 2 labels for the same person. And nodes are connected together by relationships. Relationships relates nodes by type. So loves, likes, lives with, owns, drives are type of the relationship. So for nodes we have labels, for relationships we have type. And relationships have a direction. You are forced to write the direction when you create new elements in your graph. However, when you want to get data back, you can completely abstract the direction. So you don't have to, if you want to query by both directions, you just omit it. So you can also force to query with one direction. And the very cool thing is that relationships and nodes can have both properties. So you can add weights to the relationships very easily. So the properties are key value pairs, pairs that you add on node and relationships. One very important thing is that Neo4j is a schemaless database. So you don't have an enforced schema in the background. So you can have a node person with 3 properties and another node person with only 2 properties. So there is no enforcement. You can add your own schema, so you can enforce this. But by nature, the Neo4j is schemaless. One very cool thing in terms of business and communications in the enterprise is that Neo4j is whiteboard friendly. So when you discuss a problem, when you talk about modeling, about your data, and you take a whiteboard with people and you draw bubbles related with lines, this is actually what will be in your database in 90% of the use case. But when you look at a whiteboard, this is what will be in your graph. Also, it makes things very visual. So here, I have 3 users that viewed movies. By just analyzing the screen, you can detect, okay, what do I have to recommend to user 2, for example. You just take, okay, he watched the same movies as those person, what other movies he didn't see yet that those person watched already, recommend. That's it. This is a very simple example, of course. The reality is that, however, your graph will look like this. So this is a database of activity on GitHub. So the pink node in the middle is me. And everything around is activities of people I watch, repositories I create commits to, I like repositories, I comment on issues, I open pull requests, etc. So everything around me is actually the GitHub activity I have generated, and others have generated in my neighborhood. So once you have this, you need a very convenient way of being able to query your data. Because as we see, this is not table and columns. So you need a language dedicated to graphs. So Neo4j has Cypher, which is a query language made for graphs. So there is a movement of Cypher, which became Open Cypher, so that all the databases vendors that are on graphs, like not always database, but also graph computing engines like Apache Spark, for example, could make use of Cypher on their query layer. So here, match is like a select. Between parentheses is the node and additional elements you want to add to find a specific node. So here, I'm looking for a node with a label person and a name property with value Dan. This node must have a relationship with type loves to another person with name Anne. Return me what you find. Very convenient way of querying graphs. If you already had to do with MySQL traversals, so if you take a tree and you want to traverse the tree with optional traversals, you might see here that this represents approximately 3 pages of MySQL. So here, I'm taking a person, Dan, and I say, okay, find me everything I'm connected to in 4 levels. Return me everything. That's it. So I specify *4, any relationship, find me anything. Another graph features are shortest paths. So you can find 2 elements in the graph and say, okay, what is the shortest path between those 2 people? Find me. This is very interesting, for example, if you do route planning, for example, you can find the shortest path between 2 locations, for example. Neo4j use cases are very broad because you can apply graphs to a lot of different domains. This is not only recommendations. This is the most popular use case, but it is very interesting to work in other domains. For example, fraud detection, very similar to recommendations because the algorithms behind it are very common. Network analysis, impact analysis, this is a very interesting use case. For example, when you work for a power central, you want to know how your users are impacted if you have a box of electricity in the street that goes down, who is impacted, how to recover with the less impact. Master data management, and recently, very common, knowledge graphs. So if you heard about the Google knowledge graphs, it's a graph. Very popular use case from the news, fraud detection, the Panama Papers, with Neo4j, knowledge graphs of the NASA made with Neo4j, and recently announced last year at Graph Connect, the eBay chatbot, so also made with a knowledge graph behind the scene with Neo4j. So why graphs? Simplicity, of course, because again, if you think about ways of finding users, for example, features of your user, so it can be items alike, topics alike, etc., as well as the relationships between the user and the items, can naturally be represented in a graph. So it is really natural. And the recommendation logic can be represented as a graph traversals. So we will see later, for example, I have this use case, people viewed on the website some items or bought some items. It really makes sense. It is really natural to automatically detect how to serve recommendation to the user. This is the query that would say, okay, find me Sally. She bought an item, match other persons that also bought this item. What did they bought else that Sally didn't bought yet? Return results. Neo4j will also solve the performance challenge because Neo4j made one trade-off, which is be a real graph platform. It means that it is not a layer atop another database, like some other vendors that do graph layer atop Mongo or graph layer atop Cassandra, for example. It means that they made a trade-off to represent the structure of the graph on disk. So it is with adjacency list, and so you have a bit of loss in write performance, which is less and less with the years of maturity of Neo4j. But when I'm querying for a relationship on disk, the node has all the information about the relationships he has. So it is just pointer chasing on disk until the information is in memory. So to give you an example about performance, this is a benchmark of already 3-4 years ago. So there is no concept of join in Neo4j. So there is no join. So traversing relationships is very, very cheap in Neo4j. So you can perform, you could now more, I think, but 4 million traversals per second per CPU core. So if you have a standard machine, I don't know, 8, 16, 32 CPUs, you can make a lot of traversals per second for providing users and recommend items to the user. The last technical challenge is the flexibility. This is where Reco4PHP comes into place. So it is a library we created with the experience of building recommendation engines atop Neo4j. It doesn't do things magically. It just helps you to have a nice architecture of recommendation. So it is standalone, so there is no coupling to any framework. The architecture is a bit opinionated. It is very flexible, and the thing is, it handles all the glue. So what is the architecture? You have an input, which can be a user, but the input can be anything, because we always think, okay, I want to recommend something to the user, but you can start from the other way around. For example, find me similar books, so you can create pages with similar books you might like, for example, etc. So the input, it passed to discovery for finding recommendation, and then it serves recommendation. This is where you're going to do most of your work. Scoring, we make it easy to help you to score your results. We help you to create blacklists and filters. Post-processing, this is something very interesting because, for example, if, very simple example, who knows Fabpot on GitHub? Fabien Potentier? Nobody knows? Nobody knows? Okay. All right. So this guy is the creator of the company behind Symfony. If I am following him, and my recommendation logic is, okay, who I am following, find also people following this person. So we can match, we have the same people following in common. So if you arrive to Fabien Potentier, you will actually be stuck with, I don't know, 7, 10, 50,000 users. That will be potential candidate. But how really relevant is that? So if you learn a bit of recommendation theory, you will see that generally what we call dense nodes, so nodes representing a dense person, like Fabien Potentier or the creator of Laravel, etc., those nodes will create noise in your recommendation. So generally, you will avoid it. So this helps you also if one guy has a lot of contacts in common to not over-engineer your scoring. So if you say, okay, I give 1 point for every person in common, if you have 170 person in common, this guy will always be first. But you can use functions to actually reduce and normalize actually the score that will be produced. And we help with context as well, because sometimes, maybe not for this type of recommendation, but for example, you want to display ads in the screen, on the street. For example, at a bus station, digital ads. You might want to recommend different things depending on the meteo at this particular moment. So if it is raining, you don't want to recommend sunglasses. Okay, so all those kind of things. So the design decision is that one discovery engine will be per reason of finding recommendation. The discovery engines execute graph traversals, and the items discovered multiple times are more relevant, but as I said, with post-process, you can reduce the relevancy. So very easy to install Composer. First, how to discover stuff. So you just have to use abstract implementation, where actually you say, okay, this is my discovery query. This query will actually find candidates. So you just write this, and that's it. You just say, okay, this is my logic for finding recommendation. Here, we take the GitHub example, find the people I follows. Those people are starring repositories. Return me those repositories, for example. Then I want to filter. Of course, I don't want to recommend a repository that I am already watching, for example. I know it, so you don't want to recommend. So you can just take into account the fact that don't recommend the repositories this user is watching. Then you post-process. So here, I want to say, okay, if The repository recommended is written in PHP. Add more points to this item. So you just say, OK, once I have results, find in the graph in what language it is written, and return the language. And automatically, the score will be enhanced to match this language. And the last step is to assemble everything. So you just declare an array of discovery logic, an array of blacklist, an array of post-processors, and the name of your recommender system. And then we recommend. We just create the new recommender system. My input is a user. It's me in the GitHub database. Find me recommendation, top 10, show me the results. Oh. Okay. So here, it recommends me one person, and the good thing is that it tells me why it recommends those people. So I can track, I can log, I can create analysis on the recommendations served to the user. So here, start 1 point, because we store one repository in common. However, we contributed together on the same repository a lot of different types. All right, so real-life examples, because I just want you to not think that recommendations can only be applied to e-commerce, for example, or kind of like, or social networks, for example. This is much more broader than that. And I will speak about use cases that are very in my heart, because I love those type of use cases. So we created plugins for Neo4j as well, helping recommendation. And for example, it has been used by Airbnb for their data portal. So what is happening here is that they have 5,000 MySQL databases at Airbnb. So they track analytics of the database, so when some row is created, which tables and columns are most commonly queried, etc. So they track this everything into Neo4j. And so data analysts or data scientists, when they analyze their content tables, their 5,000 MySQL tables, they actually have related content here on the right based on what they looked before and what. So you will not recommend a person table that is never used compared to a person table that is actually the activity logs of a user in another database. So they actually show the right information on the right moment with recommendation. Another use case is information retrieval. So who heard about natural language processing already? Yes, so I will not speak about this, but so you can actually take text, analyze the text to gather concepts or keywords of this text. And if you actually create those keywords into the graph and relate them to documents, you can create a kind of new search to user driven by keywords or finding similar documents speaking about the same thing, etc. So this is a use case we have a lot right now, a lot in government, for example, where actually they're very used to SharePoint. So you can connect to SharePoint, insert this into Neo4j, extract the keyword, so they actually can search in their document. And one of the best use case, I think, is improving search. So here, this is my LinkedIn. I was looking for a guy I am speaking with a lot on LinkedIn, a guy that I worked for his company, and we have a couple of contacts in common. So the thing is, I wasn't sure about his last name. I was just sure about his first name. So I type Robert, and I don't find him. So, and LinkedIn is, the first results are second level, contact, first level, but not really what I want. So I had actually to type further to find my contacts. And it is the most relevant because we have a lot of message on LinkedIn. We follow the same people. We generally comment on the same publications. So this is useful for improving search. So you can connect all this information, store it into Elasticsearch, for example, or use it real time. So you first query Neo4j, then Elastic, to improve the relevancy of the results of the search. And if you want to learn forward about this, so we created with one of my colleagues and Michael Hunger, which is working for Neo4j itself, a guide how we use Neo4j and Elasticsearch together to build powerful and relevant search experiences. So go check on DZone and you can download it. I want also to speak about bad example. Because there is one thing interesting. There are companies in the world that have the best engineers, the best data scientists, a lot of money, and they can still do weird thing like this. So 2 years ago, I bought this calendar on Amazon, Banksy 2016 calendar. What happened approximately 1 day later? Do you want to buy a calendar of Banksy 2015 for the last year? No, I don't want. The year is past. So why would you want to do that to your user? This is a very bad recommendation. Another example of a couple of days ago is this one. A person bought a toilet seat on Amazon. She said, it's okay, with one I'm fine. So I'm not a fan really of collecting them. So yes, this is, again, and you think that they're actually having a lot of money to improve their recommendation engines. But this is, I mean, something I want to remind to people because what makes a very good recommendation engines? This is not, actually, most of the things I've talked today are implementation. But for your business, implementation doesn't matter. So you can, building a recommendation engines with Python and scikit-learn, or with Scala and Apache Spark, or with PHP and Neo4j, doesn't matter. This is understanding your user that matter. And I will recommend 2 books later that are about graphs, but there is a book I read recently, which is called, good question, Contagious, okay, which actually explain how the brain reacts to emotions. And when you serve good recommendations, you trigger positive emotions to your users, and that drives good recommendation. If you go to some countries where family is super, super important, for example, in the Middle East, people will, if you serve a recommendation about makeup, for example, and I am a girl, and you recommend me something that a random person liked, or if you recommend me something that my sister liked, there is much, much more trust and emotion about that particular recommendation compared to the first one. So making a good recommendation engine is not about the implementation. It's about how you understand your users, how good you are at knowing how you will trigger emotions to your user. So it is very, very important. And for this, I do think that graphs are very good at representing access points to content, to informations that is useful for triggering information. For example, if you know how the brain reacts to how the memory is working in the brain, how it is influenced by factors, there is approximately 181 memory bias eligible for influencing how you remember information. There is much more of them for understanding how you react to emotions. So graphs are very good at representing this. I want to finish with two books that are very... The first one, Networks, Crowds, Market, is a very general book about a lot of disciplines of graphs, very general. You can download free as PDF. You can also buy the book. But it is very, very interesting. So it is not coupled to Neo4j itself. So it is really about graphs. The second one, Recommender System. It is, I believe, a very good book for people not having a PhD in maths or data science. Because most of the book you buy or recommendations are made with a lot of formulas that, I don't know, they're there, but you don't understand. Or if you read a scientific paper for AXVIF, it's cool. You have text and formulas. So you cannot argue, it's correct. So, but this one is a very good introduction. And if you want to do a lot of this with PHP, this is a very good complement to the PHP ML library that is available also on GitHub, because it introduces a lot of theory behind how the code is written. So why the code is written like this, etc. So it is a very good, two very good books. Thank you.
Any questions? Any questions at all? Oh, we have it.
I'm wondering, is there any kind of doctrine support to this in PHP? Kind of doctrine support?
Document?
Doctrine.
Doctrine. No, not for this one. So there is a library. I don't know who wrote that. So there is Neo4j PHP OGM, which is a kind of doctrine implementation for Neo4j. So it is the same type of way of working with Neo4j. So you can create models with annotations or XML or YML, and you can query the repository, take data like you would do with Doctrine, but for Neo4j. So I have to say that it is still in beta. It's kind of working, but yeah, it depends on my time availability. So, yeah.
Okay. Anybody else? Questions? Well, I guess that's it. Thank you, Christophe.
Thank you.
Okay, ladies and gentlemen, we finished a little bit earlier, so I will remind you to have fun at our middleware track and use the activations. Lunch will start at 1 o'clock sharp, and I will see you back here at 2:30. So take your time, enjoy the beer, enjoy the games, win some great presents. See you here at 2:30. Thank you.